You guys good with the video?
Bro, just to check. Alcune volte lascia là.
There's no one on me, Deco. Do you want to start, or did you want to wait?
Let's give it like 1 more minute. See if I can get started just so I can take minutes. Like my drive is stuck at the physics stage.
Oh gosh, it's great timing. It's great timing.
Like I said, whatever came go wrong, first time. But it's moving now, so it should get excited. Yeah, I want to have the IETF resources. good. One last thing to bring up.
Every time we meet, I feel I'm learning again. I never remember how to go and take it.
Yep, so I think we're good.
Yeah, good. Yeah.
Ooh, totally should have.
Somebody told me we have it doing something.
It does exist. It's not virtual.
Good. So, good afternoon, everyone. I'm Rashad.
And I'm Jeff.
So this is BFD for IETF 101. I'm assuming everybody's here for BFD. This is the note well, which you should all be familiar with right now. Everything you see here belongs to IETF.
If you haven't read this, at the very least, your lawyer should have.
Next.
So as of this meeting, we have a new area director. Martin, stand up and say hello to everybody. I'd like to thank Alvaro for putting up with us for so long. It is now Martin's turn to have some fun. This will hopefully be a relatively peaceful working group for him. Slide, please. So document status. The multi-point and active tail document has been sent along to ISG. And as of like a few minutes ago, I just did the exact same thing for the BFD Yang document. So congratulations to all the people who put work into that and the working group for moving those along. The Yang document in particular was a long journey because of the IETF as a whole had to get along with learning Yang and what it means, and writing manageability stuff is not easy. Since last meeting, we did adopt the BFD for VX LAN document, and we will be getting a brief update on that this meeting. We've had requests for last call from authors for the authentication related stuff, specifically the secure sequence number document, the BFD stability document, and the optimizing BFD authentication. So those last calls will begin after IETF. We also had substantial commentary on the mailing list relating to some comments about RFC 5884 edge conditions, specifically about getting the sequence numbers up and whether or not LS ping responses were actually mandatory. I think we came to some level of consensus as to the expected behavior, especially with comments from the original authors. However, there's been enough commentary that even with an errata, we may be in need of some additional text, so a BIS document may happen. The original authors for a BIS document are usually given right of first refusal to actually update the document. We'll be contacting people about that, but obviously we can add on additional authors if they're not particularly interested. Greg Mirsky will actually be going through at least a piece of this problem space as part of one of his presentations. So documents to watch elsewhere, draft Chen BFD unsolicited. This will be presented this meeting by me since the authors were unable to make it to London. RSBFD, which is part of the motivation for the BFD unsolicited for doing BFD to BGP next hop, specifically in a route server context. VRP VFD is an active document in the routing working group at this point. There are several documents from Greg spanning a couple of working groups, which you'll be giving updates on this session. Greg.
Yes, actually, in RTGVG, There is another document related to use of BFD in VRRP environment, and that discusses their use of point-to-multipoint BFD. And as I was told by the chairs, they will start the working group adoption call on this document after the meeting.
Okay, before you sit down, Greg, one piece of my understanding is one of the reasons this did not stay in the main document was the point-to-multipoint does have IPR considerations.
It was updated, and to the best of my understanding, so there is a way of avoiding this IPR. Again, it's only to the best of my understanding of.
Also, regarding related documents, I believe there's a draft Ali regarding use of BFD for Spring, and there's been some discussions on the mailing list for that. It's not on this list, but it is.
Right, yeah, actually, that's a very good point, and I think that BFD working group experts can look at this and see whether what's a point being made in the document and whether it's necessary, because we have already RFC 7882, which addresses the use cases for seamless BFD.
So this is the set of presentations that we'll be going over as part of this meeting. Very brief update on the Yang module, update on the VXLAN stuff, current status of the performance measurement document, presentation on the unsolicited BFD, a discussion prompted by Greg for the BFD bootstrap. One of the things that I would like to suggest for that particular slot is Greg's presentation followed by room discussion, so we can get some initial sense as to how we might proceed. Demand mode for BFD, point-to-multipoint BFD over shared media as a set of problem spaces. And if there's time permitting, I have a trivial document that I've submitted at the last second. And if that slips out, that's perfectly fine. I'll take it to the mailing list. So first one is BFD Yang.
So this is a quick update on the Yang model. There's been a few changes since we last met, which I believe was in Chicago. As Jeff mentioned, he clicked on the Submit OK button, so we hope there won't be too many drastic changes from now on. The changes since Rev 5 of the document, we had comments from work group last call, and we got quite a few comments from the Yang doctor. We had comments from Jeff also, which we discussed last year in Prague. So in no particular order, we added a grouping for the BFD clients to use. That was especially for the IGPs, which auto-discover their peer. So that was to make the Yang model more usable. The security consideration section was lacking. Something pretty trivial, but we had a container. We didn't have a container around this, which is the what's done usually. We did add working XML examples, working being the important word here, and there were various clarifications and nits, which we fixed. This slide is actually a little bit out of date. All the comments from the Yang doctor on Rev 11 and Rev 12 have been addressed, and I guess we're going to get a Shepherd write-up soon, and done? Okay. And so then that next step will be to look at that and to address any issues. And as Jeff said, thank you to everyone who participated. It's been a long ride. It's not done yet.
Soon done. Okay, our next presentation is going to be BFD for VXLAN.
So, Greg, I'm sorry, the clicker isn't working, so just go on and say next slide. Just wave.
Yeah. Whistle or something.
Okay. Yeah, next please. So this is a status update on what the document describes, and for the VXLAN, because it does not support multi-protocols, that the payload has to use Ethernet encapsulation, and it can be used to verify continuity between NVEs. In discussions, we found that there are already implementations in the field, and one of them in open source. We don't have a report on interoperability of these implementations. That definitely might be interesting to explore. Next, please.
Sorry, Greg, do you know if how far from this document the implementations are? Are they close to being compliant?
They're compliant because, as I understand, contributors to this document participated in implementation.
Can you say who they are?
I need to ask them if it's okay with them. So this is just a capture of what their BFD packet, control packet encapsulated in VXLAN looks like. So we have to have outer Ethernet and IP encapsulation, followed by VXLAN, and then followed by inner Ethernet and IP encapsulation, followed by the BFD control payload. So the recommendation of encapsulation and encoding is that for the inner Ethernet header, destination MAC address is either dedicated MAC address, and for that we'll need IANA assignment, or it's MAC address of destination VTAP, and the way of learning this address is outside the scope of the document. Source MAC address, obviously it's originating VTAP. For their IP header, the source IP address, obviously their IP address associated with the VTAP, and destination is a destination VTAP IP, one of the IP addresses. We still have an open question that we appreciate the working group consideration, how we use IP addresses of internal encapsulation, because that's one of the areas where could be done some interesting things. There is no any input from the implementations, and if there is no special consideration, we'll just remove this editor node and leave this description as is. So the TTL of the inner IP packet must be set to 1, and UDP port used is 3784 by single hop BFD specification. Next slide, please. So that is it. The document viewed as a stable, and we appreciate the comments and consideration for the working group last call.
Okay, so you think that we're actually, even with the open question about address selection, ready for last call?
Well, I would probably put it in this order. First, let's give some time for people to read it, and if they have some comments, send the comments to the list. But if not, then we're removing this editor node, and we're ready for last call.
Okay, thank you.
Out of curiosity, how many people in the room actually read the draft or peeked at it? Okay, so we need more. Thank you.
Okay, our next slide is going to be PFD performance.
All right, I'm going to talk about PFD performance measurement. Ashish, who really wrote most of the draft, could not make it to this meeting. Before I get started, I want to make a couple of comments. the draft might make suggestions or forward-looking statements that might imply a newer version of BFD, and I'm not going to deny it. But the purpose of this particular document is still to see if there's some kind of performance measurement we could do that might either justify the need or not the need to do the next version of BFD if there's such a requirement. Anyway, with that said, BFD in general assumes a link with if a fixed characteristic. If a certain timeout interval is set on that, it does not change usually. It'll either stay up or go down. So, and of course, the other assumption is that it's low latency and low jitter. The idea is that not all links behave that way. Specifically, there are these satellite links, and new geostationary or otherwise, whose characteristics change all the time. So the problem is trying to figure out what interval to set on these links. So this study is to try to figure out, A, how to A, measure, and B, how to optimize that interval that we actually want to set on that link. Next slide, please. So the suggestion is that we use something that's already been defined in RC 6374 for delay measurement and override it with the BFD auth type. Now, next slide. We will recognize, as we say later on, that the overloaded BFD auth type is not extendable today. So that is an issue that we believe we still need to resolve. But to go back to why we believe this study is needed is the idea of how to tune the BFD interval based on link characteristics is not well documented. Even if people have knowledge of it, it's not very well documented. The other is that it's, of course, a self-contained mechanism since the measurement happens within BFD and there are no extra frames that have to be sent as a result. Yes, the payload is slightly bigger because you're carrying the timestamps, but at least it's happening in the context of BFD itself. And of course, the third argument kind of contradicts the second one, but yes, some WAN links are sensitive to sending extra data that is just meant for measurement. So we're trying to see if we can minimize it, but yes, the payload is slightly bigger with this. So as I said before, we do realize that the auth type is not extendable, and how that measurement performance is translated to the actual calculation of the BFD interval is very, very implementation specific. But again, the point being that 5880 or anything related to it does not quite still define the mechanism for determining what that interval is. Most of the time, it's a guess on the part of the operator to figure out what should be the interval and hope that that works. And usually it's trial and error to try to figure that interval out. This is hoping to go into a direction where rather than trying to guess, we do an actual measurement and then figure out what the interval should be for that link. Questions?
Yes. Hi, Greg Mirsky, ZTE. So we just a preface. We already had a discussion with Mahesh, and I appreciate the answers to help me understand the scope and mechanism used. So just if somebody haven't read it, my understanding is that it will use BFD echo.
Right, and I think I replied, and Jeff actually corrected me, is that if we make that assumption, we don't know whether the other end is going to support it.
Yes,
so
that's first. Another thing is that the larger uncertainty is we don't know what's the format of BFD echo packet is, because 5880 does not specify what is being sent in BFD echo mode.
Fair enough.
Which is okay, because probably it's time for us to specify and seek feedback from implementers who supports BFD echo. As far as I know, very few implementations do support BFD echo mode. So that's another hurdle. But if I understand correctly, what you are measuring packet delay over single hop layer 3 link. And in that context, I wonder why it's important to use BFD specific packet where you just looking for how long it takes for the layer 3 packet to traverse this link. The link can have layer 2 equipment or layer 1, but it implies, echo mode implies that there is no layer 3.
I don't know why you would think that this is single hop.
No, because echo mode
Okay,
works
fine.
only on a single
Right.
mode.
So if you
Single
assume
hop.
right? If you assume echo, yes, but I take back that statement saying that it is that we are suggesting only echo. So think of it as
Then you have a huge complexity of how you collect all the timestamps, because if you use asynchronous mode, that each node sends its packet separately. So how you transport timestamps from their ingress to the egress, I see it's unnecessary complexity, and you can use two-way active measurement protocols, and then you can extrapolate your measurement results because it does it over UDP. So it's pretty close to what BFD will experience.
okay. So first of all, I think if you could go back a couple of slides. So sorry, yeah, the next one, please. Yeah. So we're pretty much saying that we're trying to follow what's defined in 6374 for how to collect or what timestamps are collected. Now, as far as the actual timestamp, it is that is collected at well, initially when it's transmitted, it's what the sender will put in T1, which is the first timestamp 1 field.
Yeah, but
And timestamp 2 is similarly the receiver's, and then you're sending the same, you're copying over.
So hold on a second, please. We do have a comment from Jabber, which thankfully somebody's pasting into the Etherpad as I'm looking at because I couldn't get onto Jabber. Ashish says that, are we in agreement that the issue proposed in the document is real? If so, they're flexible on the actual mechanism.
Right, okay.
Okay, again, I understand that there is operational issue. I'm questioning to use BFD to measure BFD, because we can use existing active IP measurement tools.
Okay, a couple of things. Of course, you can't quite get the rate intervals measurements
Why?
with TWOM or any other protocol that you can get with BFD, not the millisecond rate of detection
No.
intervals that you want.
Excuse me, why not? Again, are we talking about implementation deficiencies?
Okay, so number 2, and if I can just finish the second, is that if you're trying to figure out the detection interval of BFT, why would I go measure it with something else rather than BFT itself, which has the capability or can be made to have the capability to carry timestamps?
Because even in the transit nodes, even if you have multiple IP hops on your path, it doesn't matter whether it's BFD or not, because they just forward this traffic. So, and in the measurement, you should ignore the processing by the host to do the measurement, because you're only measuring effectively what you are measuring, their transit delay on this path. So regardless of what packet it is, it's your host processing by the ingress and egress of your test points should be excluded.
I am trying to determine the detection interval of BFT, right? So if I'm trying to do that, what better source of that measurement would be than BFD itself, right?
So I actually would like to ask a question about that. So the whole point is you're bringing up BFD because you want to have the up-down behaviors that BFD give you. That's good. You're trying to tune it to actually have a reasonable lower threshold.
Mm-hmm.
The problem becomes you have to be careful about tuning it down, and then the session drops before you would actually get additional performance information from it back. So while I understand your use case and think that it would be good to figure out a way to allow for some level of tuning, the draft I did with Xiaomin for using BFD Echo for testing PathMTU sort of recommended setting a higher detection multiplier and allowing for dropped packets to do this sort of thing is an example. But that was using Echo to actually carry that test out as a side thing. So for single hop BFD, I think you can actually get away with using Echo as part of your probe mechanism, or as Greg is suggesting, an alternate channel. But I think that trying to actually carry out self-tuning within async itself may be tricky at best.
So if the interval is set, of course, high enough to begin with, and the idea being that you're not dropping packets because the detection interval is too low, it would be that you're collecting enough samples to figure out what the interval should be, whereby you would drop the minimum number of packets. So you wouldn't start off with a very aggressive detection timeout.
I understand. You started with something higher than expected. You expected to tune itself down, and then you need to actually have it self-adjust past that point. But for a lot of BFD applications, much of what you're looking for is that you support at least whatever the negotiated minimums are. And if you can't support that, why look for self-tuning?
Largely, because especially with links and latencies that vary over a period of time, it's how do you come up with that time interval? And we have other ways, I guess, otherwise we'll have to go figure out through some other ways what the interval should be.
And Ashish also passes along that they would like to invite collaborators to iron out the mechanisms for self-tuning. So I'm going to suggest to you, not speaking as chair, self-tuning within BFD itself might be the thing to discuss, period, before you get into how do you make it self-tune.
Okay.
Further commentary? Okay, we're on to our next presentation.
So actually, it's a question more for Ashish, but so my understanding of how this came along is that this was not something theoretical where it's actually problems which have been seen in those kind of environments.
I'll see if Ashish will respond on Jabber.
He says yes. And he replies also that this is an issue that we face in non-geostationary orbit satellites. So that was somewhat the case that I was expecting out of this, that you have some level of variability. And while I understand that in such situations, the detection interval might actually be somewhat periodic. There are times you can be more aggressive than others. It seems to me that what you should tune for is basically the worst case.
Yeah, actually, just came to me that might be interesting as well for BFD over microwave links, because as microwave links can change their bandwidth available based on external environment. So going to the less aggressive intervals to ease condition for their service traffic might be interesting scenario, but again, that would I'm very, very, very concerned about auto adjusting algorithm and mechanisms because sometimes they produce unexpected results.
And final comment from Ashesh, and we're out of time for this presentation. The reason for auto-tuning is that we have tens of thousands of terminals, and with each of them with different characteristics, they can't all be manually tuned to provide reasonable performance. And so again, while I buy the use case of, you do want to figure out what the timing is, using BFD, the self-tune, may not be thoroughly appropriate. So that's the discussion I think is that's worth having. Okay, our next presentation is the one from Ankur Chen.
Also, we don't
Unsolicited.
have Rob.
No, Rob Rashik was unable to make it. They've asked me to present in their place since I understand the thing. Should be posted. BFD unsolicited. Yeah, that's it. Probably a PDF form.
Oh, that's what.
Okay. Okay, so I am presenting this on behalf of Ankur Chen, Naiming Shen, and Robert Rashuk. This is BFD, BFD for unsolicited applications. The motivation for this, and this is me reading between the lines, this originally came up in the context of the route server BFD document, which I'm one of the co-authors on, covering exchange point environments where the next hops themselves aren't something that need to be tested because of the deployment scenario. Moving on to their slides, their problem statement is that explicit configuration or registration is required by both sides for current BFD protocol. In this case, they're talking about 5880, 5882. So this works well for sessions that have applications that have sessions. For example, BGP is configured, OSPF is discovered through adjacencies through the Hello protocol. But this is too restrictive and difficult for applications without sessions. Next slide. So examples of these types of applications, static routes is an example. Nextop can be set up to be monitored using BFD, but this typically requires configuration on both sides, and only one side may need the actual tracking going on. The current workaround is configuration is done on both sides. In the case of BGP, third-party BGP nexttops, this is a nexttop received from a BGP speaker that happens to be appearing on one address where the nexttop is not the same address. This is allowed by the BGP protocol in general, but is extremely common at internet exchange points, via route servers. And partly this is a problem because there is no direct BGP session between the BGP speakers in this case. It's proxied through the route server. Next slide. So the procedures that they're suggesting for unsolicited BFD is that one side plays an active role, and the other one plays a passive role. Only one side actually initiates a session. The passive side accepts connections from the active side. It's not written here, but effectively in a wildcard mode, and that the feature should be run only on a per interface basis, and that the BFD parameters can be interface or router based, and that passive roles may change to active roles depending on situation. Next slide. Now, obviously, the biggest issue here is that by allowing this sort of wildcard BFD configuration, this obviously causes greater security issues. So their security considerations is that the feature should be limited to specific interfaces and to use GTSM where the TTL is set to 255. That the environment is the feature is only deployed in trustworthy environments. For example, internet exchange points or between a provider and customers. That access lists be provided so that subnets and hosts are used to say what we're willing to do this. And of course, BFD authentication could be used Although in the exchange point environment, this is probably something that doesn't make a lot of sense. Next slide. So the next step, they're asking for working group adoption. The point I had made to them is that this is partially covered by some of the solution space that SBFD was originally defined for. That said, one of the reasons why this is being suggested is that 5880 style BFD is very common and well deployed, and this is basically a very minor change to an implementation. As an example, I asked our own BFD developers what it would take to do this, and sure enough, at least in the Unix-like code, we already use a wildcard listen to actually catch things, and authentication is done before we call the accept on the socket. I suspect this is common for a lot of people. So for some BFD implementations, this may be a trivial change versus moving to the SBFD initiator and replicator, reflector. Thank you. So at this point, they're asking for adoption and discussion. Les.
Yeah, Les Ginsberg. So useful stuff. My question is there anything here that's subject to standardization?
So the amount that's worth standardizing literally is we're allowing BFD sessions to be configured with wildcard catch 5882. It has a very specific set of demultiplexing procedures. This is a very, very minor change.
All right, I could be wrong, but I think there are people already doing this. So I just don't know what work there is here.
I'm Greg Merskiziti. So I double check its informational status, at least intended by authors. So they probably don't intend to be any IANA consideration or any updates to 5881. So is that the case?
Yeah, that's what I think partially for the working group to conclude for consensus purposes. But as I said, even if there is a change, it's very tiny.
I read the document. I didn't see any changes that needs to be done. If anything, there might have some impact on a Yang model because it expects to do certain things. But we can verify whether Yang model can accommodate this use case.
And speaking from the top of my head, I suspect that all might have to be changed is to add a new session type.
Why? Because actually setting remote side in the passive mode, it's a normal practice.
But the single hop session table is there's no way to configure a wildcard in that at the moment as a key. That's effectively what they're doing here is just wildcard receive.
Right, but that's only for the data model then.
Exactly.
Yeah. Okay. So again, we can check with the data model, and either we want to make change now or be proactive, or just say, okay, when this needs to be advanced, we can make change to the data model.
My preference, individual contributor, Yang model, is to wait and not to jump on the bandwagon too quickly.
And I support that.
In any case, I'll prod the authors to carry further discussion out on the list. This is largely to socialize the idea. And Les, if you do know for certain that there is implementations that outright do this, as I mentioned, it's a trivial code change. I don't think there's any interop issues, and as an informational document, this might actually be fine. If not, we could decide that there's nothing to be done. Yes, so it is now time for the Greg Show. The first document that we have is Bootstrap clarifications.
Greg, have some water before you start.
Yeah, right.
Thank you. Okay. Again, as Jeff mentioned in status update, this is intended to be as a trigger for discussion on 5884 bis. And this started with some errata discussion that we had in the list around their meeting in Singapore. And first I presented it to Mpls working group back then. But then we decided that expertise in BFD group, and we need to decide it, what we do. So what is seen as under specification in 5884 is how active BFD peer bootstraps BFD session over Mpls LSP. The 5884 requires it to use LSP ping. And LSP ping has to carry BFD discriminator TLV along with the FAQ. So when everything verification, when LSP ping packet being validated, then their remote BFD peer expected to allocate local BFD discriminator of its own, use BFD discriminator arrived in LSP ping, and send BFD control packet to their initiator. And what to do with LSP ping itself, it's originally been left unspecified. In a discussion, that was clarified, and now there is more clarity, but it's still kept as errata. So because the sender can choose a different return mode. It can say by default return over IP, or it can send do not return. So now the text clarifies that the act of remote BFD peer has to be guided by the mode set by the sender according to RFC 8209. But then the open question is what to do with the BFD discriminator, and in what manner, if reply is required, the receiver of echo request should reply. Because sending its own BFD discriminator does no good. So it's not helpful because you cannot really identify BFD session by someone's BFD discriminator. You can only demultiplex using your own BFD discriminator. So then two BFD discriminator TLVs should be sent out, or we need to come up with a new BFD, new TLV that includes both. Actually, what I suggest is to do something that will add clarity to the bootstrapping process, and say that, next slide. So the sender, the ingress LAR should set reply mode to no reply, which will eliminate any confusion on a egress LAR. But at the same time, I think that should is good enough, because some implementations may already be using default, which is reply over IP. Should be okay. Responder, there are two options. So either egress should not include BFD discriminator in Mpls LSP echo reply, or we say that ingress LAR must ignore BFD discriminator TLV if present in Mpls LSP echo reply.
So one option has an optional behavior saying should, the other has a mandatory behavior. Why don't you just say it may ignore it instead of must?
No, but may, again, may now is already, it's part of 8209, because there are so many different options of how to set reply mode. So we don't need to specify which are already part of 8209. But if we want to make the process more definitive, then we need to say which mode is preferable for bootstrapping BFD session over LSP.
My question is, you're saying should not send it. Okay, that's fine. I'm fine with that. So on the way back, you say you can either say should not, in which case he might do it, and then what do you do on the other end? So I thought we should just say may ignore it instead of must ignore it.
Well, because again, if may ignore it, so what it doesn't ignore and how it interprets what? It's implementation specific? Because again, if we have two LERs, right? So one which will include BFD discriminator TOV in the reply, and another will do some conclusion based on that, which are not specified.
Well, it's passed up to whoever asked for the ping to be sent in the first place. I mean,
Yeah, but the purpose of the ping is only bootstrap. The purpose of the ping is not to verify continuity.
No, but some application want it, it has a matter. Mostly, it has to do with implementation. Okay, and it's just at this level above BFD, they like a ACK. I mean, my memory is very hazy, but
Right, but
one of our implementers asked for it, so
If I may,
I don't even know if it's in our implementation or not. But at the time, I was discussing this with Rahul, and it came up.
The two sort of meta points that popped out in the working group this discussion. First one was, should you send the reply? Some people are expecting it because you're doing a ping, and if you ask for a reply, you should get it. The second issue is when you do get a reply and you get the discriminator and it's inconsistent with what BFD almost immediately is going to send back to you. What do you do about that? So the first piece about whether you send it back or not. The answer on the list was basically follow the procedures of LSP ping. So if you were to bootstrap your session without this, should it work? Probably so. Should you get the reply? Only if you ask for it. But once you actually do get the reply, what to do about inconsistent stuff? That's an edge condition that was left out.
Yeah, and I don't know why anybody would request this piece of information, but I don't know why we need to specify that they can't do anything with it if they request it.
Yeah. So again, for the reply, the underspecified is whether in reply BFD discriminator should be included, and if included, then what value it should be set to.
What value? What is set to?
BFD discriminator value of BFD discriminator TOV.
I'll have to see if I can find some history.
Martin, speaking as Martin. What are you afraid that could happen if you get a discriminator TLV? What do you think the ingress could do wrong?
Well, what I'm afraid of, if they will start matching to BFD discriminator of their session and say, okay, there is no match, or I cannot find this BFD session, and thus it failed. So basically that they would not properly correlate with the state of BFD session that was just bootstrapped. And thus it will get some confusion between what's being reported, and probably might try to send another OSP ping with a bootstrap or something else. So basically, the authoritative state is BFD session. The LSP ping is a bootstrap mechanism, and it's not to be used, it's only to be used to validate that the FAQ is correct. And then it should take the BFD discriminator of the egress, of the ingress, and pass it to the egress to use in BFD control packet. So, and that's it. It performed its role. That's why I would recommend to suggest to use no reply, because actually reply from the egress serves no purpose.
So
Okay,
I'm sorry to jump in.
yeah.
I agree with you. The reply doesn't serve any purpose. Where I disagree is I believe the egress node is sending its local discriminator, and not the ingress, the discriminator on the ingress node, and that discriminator is useless.
Well, again, okay.
So
50
this is back to what Martin was just saying. Nothing bad is happening, in my opinion.
No, but again, 5884 doesn't say what it will be sent in a echo reply.
It does not, as in it doesn't say whether it's local or
Yes.
remote.
Yes, it even doesn't say whether BFD discriminator should be included.
No, it does. I mean, that was the whole purpose of the errata, to clarify that the may was applying to the discriminator and not to the echo reply. But discriminator is mentioned there in 5884 for sure.
No, only in request, not in reply.
It's mentioned in the, I mean, we can look at that after if you want, but I'm pretty
Yeah.
sure it's in the reply.
Okay. Yeah, but again, the thing is that when we send the reply back, how it to be demultiplexed, because the ingress cannot use egress local
No, I agree. I
discriminator.
mean, that's where I agree with you, where I'm saying that discriminator is useless. But where I'm disagreeing with you is I believe nothing's broken. We have useless information or unneeded information. Or you could say, to optimize, we don't need that. But the bootstrapping process is not something which is frequent. So to me, I don't view that as being a big issue. Again, I'm talking as Rashad.
I think, well, second comment, but I don't want to last long. You're setting a requirement on, well, I understand, I think I understand that you're concerned by the value. Here you're setting a, no, okay, I was about to say, okay, no, forget it, but I don't think I'm under the impression that I don't think we need such a hard constraint. If you receive it, it's up to you to decide whether you want to do something wrong with it or not. And you're responsible for the wrong things you do within a degree of freedom that was left in the original specification.
And the whole reason we're here is that this ambiguity
Yes.
has caused interop problems. So
Yes.
well, I agree with
Here.
you that if this was harmless and no, this is
Let
not
me
causing
clarify my suggestion that yours says put in that should not or a must. I would make it should not and may. Does that help?
In responder, you suggest
What
that,
I'm saying is that the responder may send this. I mean, it should not send this, okay? But if it does, the other end is may require.
And just because our AD hasn't learned that the people on the other side of Mideco can't hear us, there's an egress behavior and there's an ingress behavior, and they may not be consistent from the perspective of the document.
So, I mean, that's what I'm saying. There's two separate sentences. What applies to
this is part of the solution space, but I'm afraid to say that we've hit the end of the time slot here. We can continue if we have anything left, but what I'm going to recommend is, so Greg, the way I read this document is that this could be like the start of the considerations for BIS, but this would probably not be the BIS document itself. Would you agree?
Again, I would like to have this agreement in a group of how to resolve this issue, and if we conclude that we have some change to apply to 5884, then this change will be applied to 5884 BIS.
Right, and I guess my point is this is a good document to use as a starting point for formalizing the solution. Okay,
Yes.
So let us continue this on the mailing list, and as I mentioned, the original authors of the document get right of first refusal, and it's up to them whether they take on additional editors. But they will certainly need this discussion to be finalized in the working group before they can start text.
Right, and then just extending to the idea of 5884 BIS, we already have text from the earlier discussion that worth adding into the document because we spent so much time and we don't want to do it again.
Okay. So moving on to our next work item, this is the Mpls demand mode.
Yes, thank you. Again, I had made some presentation in the Mpls working group, and now would like to present it to the BFD. I apologize if you already saw that and had to listen it again. So RFC 5884 defines use of only asynchronous mode over Mpls LSP, but there is interesting property of the demand mode that I believe are beneficial to use for Mpls LSP or Mpls data plane and BFD over Mpls data plane period. So in asynchronous mode, just to refresh in one sentence, both ends of their BFD session are sending control packets periodically, asynchronously. And demand mode is such that the node that being put in demand mode does not send periodically control packets. So we can go to the next slide. But the node that is in demand mode may send BFD control packets with a p-bit set if something changes. Next. So what's the idea? Idea is that we bootstrap BFD session as defined in RFC 5884 and bring this session to the up state. And once the session reaches up state, the initiator of BFD session puts its remote peer in a demand mode by setting the flag in a pulse sequence in a BFD control packet. As a result, we expect in a normal operation that remote node B in this diagram will go into demand mode, thus cease to send periodically control packets. Next slide. If we have unidirectional failure, that will be detected by the node B as missing of n consecutive packets defined by the detect multiplier, and that will prompt it to send BFD control packet with a p-bit set indicating that lost control. So it's a I think it's bit 1 in a code point 1 in a diag field. Actually, I prefer to refer it as a MPLSTP definition as RDI signal. Once node A receives this information, so it sends back over IP control packet with the F, with the final set to acknowledge that I hear you, and goes into sending packets over Mpls LSP at 1 second interval. So basically, by figuring out that there is a unidirectional failure and they need to start operating as bringing up the session. Next slide. So, can we go back? Sorry. So once their defect condition being cleared, again, so because node A sends its packets with the demand mode cleared, node B will come up into asynchronous mode. They will form again BFD session and bring it to the up, and then here we go again. Node A puts the node B in the demand mode. So that's the idea. Common suggestion, questions, welcome, greatly appreciated. I had exchange with Jeff about it. Jeff believes that everything is very obvious and should be known. So I would like your opinion on that, whether there is any interest of the working group to have this document as a working group document now or in the near future.
Who has read the document? Okay, so how to foster interest on the alias?
Okay. Okay, let's go next. Next. Yeah, I think that this is even simpler. So point to multipoint BFD, because it does not have three-way handshake, so that demultiplexing BFD packets cannot be done by your discriminator in a receive BFD control packet. It has to be use source address, my discriminator, and identity of the multipoint tree. If someone uses point-to-multipoint or BFD for multipoint networks over point-to-multipoint LSP, and their base specification recommends use of IP encapsulation according to IETF101, when the destination IP address is Martian address and the source IP address of BFD control packet is the address of the sender. But with the older trend that we observe now, with the like sunset of IPv4, we can expect that this IP encapsulation will be IPv6 encapsulation. In our opinion, it's too expensive to use IPv6 encapsulation for BFD over Mpls LSP. So thus, if we remove IP encapsulation and use what can be referred as ACH format, then we need somehow to communicate their source address. So the next slide. Right, in the next slide. So for non-IP encapsulation, we need to do extend define source map ID, IP address TOV, and include it in BFD after BFD control packet. So that's pretty simple. And how to propagate my discriminator. There is very nice proposal for multicast VPN to use BGP BFD attribute. Other ways can be discussed as well. So, for example, we have proposals on use of point-to-multipoint BFD for VRRP and for PMSM over shared media. So they can, again, if there's a MPLS, then they can use this approach, but more likely it will be just straightforward IP because it's a single segment. So there is no need even to have any MPLS complexity. So again, comments, questions, working group adoption consideration.
So one question I had was, so I think your document says BFD working group, but the way you've named it, it seems to be MPLS. So
okay,
that was not clear to
I
me.
can explain. I agree that that probably more in the domain of MPLS working group, and I think that originally, and I did present an MPLS working group, but then when we talked with Jeff, he suggested, okay, let's present it to the BFD working group and see what the BFD group thinks. So if there's agreement of BFD working group that it belongs in MPLS, okay. I would agree with that too.
Do we have a George comment?
I'm planning to resign as the end of the MPLS meeting tomorrow, but I would agree for what a lame duck can say.
Agrees that it should be BFD?
Yeah, I'm sorry, I did not get that either.
You agree that it should be MPLS? You should be BFD?
Yes, so, I mean the original was done over there, and but it has to be. You know,
Yeah.
we don't want to screw something up over there that you guys would catch.
And I will just extend, because actually the only change that proposed here is to the registry that being defined by MPLS working group. If we keep it in BFD, that will require us to communicate with the MPLS working group. Doing an MPLS working group seems to be make it the whole process much easier and logical.
Yeah, and no changes to registries or something that's easy to coordinate.
Right. Okay.
Thank you, George.
Okay, my show continues.
Okay. And while we're moving to the next slide, who here has not signed blue sheets?
Okay. I already mentioned these two drafts that provide document use cases for point-to-multipoint BFD being used in VRRP environment and in a PMSM. The motivation for VRRP is that VRRP v3 does allow to have sub-second intervals, but use of point-to-multipoint VRRP seems to be logical and much easier to do, especially with a little extension to VRRP, so that master advertises its discriminator and can bootstrap the point-to-multipoint BFD session on other members of VR ID group. So the details are very simple, how it works and how the sessions can spawn and terminated, and what happens when the master goes down and the new master being elected. So obviously it assigns locally its new my discriminator and starts advertising, and all other routers who fail to become master, they will start listening to new my discriminator and IP address. Actually, IP address will be the same because it's a master IP address, which is a virtual IP address. Okay, we can go to the next slide. Yep, that's already covered. So this is an extension, and we include just a master discriminator after their address list. Next. Yeah, that's already covered. So for the PIM, I apologize for the very light color that makes it hard visible. So the idea of PIM-SM routers on a shared segment, it comes from current version of PIM-SM, which requires that DR to be elected. DR elected in PIM-SM implicitly so that each node listens to hello messages, and each router may be assigned priority, but the tiebreaker could be if priority is either equal or absent, is not configured, then the tiebreaker is IP address. So one way or another, the DR will be elected by everybody on the same shared segment. And DR has a special responsibility for directly connected hosts because it sends join messages to rendezvous point. The current implementation or the current specification of PIM-SM results in a detection of DR failure or outage in 105 seconds. The use of BFD allows us to do the sub-second detection. So even though in this diagram only two nodes are connected to the same segment, in more general case, we can imagine that there will be more PIM-SM nodes on the same segment. So thus, use of point-to-multipoint BFD seems to be a nice option. At the same time, use of point-to-point BFD does create unnecessary state on DR because effectively DR has no interest in the state of other router on another end of BFD adjacency. So next slide. So the proposed solution is to use point-to-multipoint BFD and use PIM-SM hello message to do the bootstrapping so that the router which elected itself or realized that it's a DR will include this optional TLV with its locally allocated discriminator to do the bootstrapping. Next. So this is just a snapshot of what PIM hello message looks like, and it has a number of options that use TLV format, and the new optional TLV follows the same with the 32-bit long value that carries my discriminator allocated by DR. And if DR stops including this TLV, that should lead to other non-DR nodes on the same segment to stop listening to BFD. So next. Again, it was presented to PIM working group, and they think that it's interesting because there were comments saying that yes, there are implementations that use point-to-point BFD, and in more general case, when there are more than two nodes, the point-to-multipoint seems to be a natural and logical vehicle to do that, because again, there is interest for expedited detection of DR failure. Again, PIM working group has DR enhancement working group document which introduces notion of BDR, And this proposed mechanism very nicely can be used by BDR, so other nodes can monitor BDR behavior and do BDR election in expedited way. And actually BDR learns the state but doesn't act on it, so the convergence from DR to BDR is stateless. And again, as I mentioned, I was told that RTG-VG group will do the working group adoption call on first document after the meeting.
Well, thank you for bringing this to our attention, and obviously poke the mailing list if you want a specific comment on this.
Obviously, I always appreciate the comments.
Okay. And I think that brings us to our last, hopefully very brief presentation. So this is work that I'm doing with Albert Fu from Bloomberg. So the problem statement is, there are applications that run across multiple hops that need a consistent MTU to behave. Financial applications are a good example of this. They tend to run over things that are not TCP because they're real time. Dropping packets ends up being very, very bad when that packet contains a financial trade, as an example. When something goes awry, as it seems to often do, based on stuff that I hear from my customers, and I suspect you've heard from your customers, they can be very difficult to troubleshoot. Sometimes this is because the path that's being provided is provisioned over things that are label switched, and the label death may impact the MTU. There may be issues with aggregate Ethernet. Pick your favorite headache. Problem being that you can't actually see that the MTU is actually free and clear all the way through. LSP ping does have facilities that do some level of this stuff, but it's obviously not meant to be used at extremely high rates. So question is there something we can do about that with better speed? BFD has at least some of the right shape for this, but the sort of general problems that BFD PDUs just aren't all that big. Matter of fact, our BFD length in the protocol is 1 octet. 255 bytes is even close for most of these applications. Next slide, please. So the proposed solution is taking advantage of a clever bit of hackery. The Daves, when they were specifying 5880, intentionally didn't talk about how the encapsulation in IP actually worked. And this is to some extent something that's been held in our back pockets for a while. They have experience in IGP land where they did sort of the same trick eventually to add on authentication onto OSPF as an example. Since it's not specified that the encapsulating IP, UDP, or whatever transport you have on top of IP is for BFD, you can make it bigger than the BFD contents. The protocol specification is very clear about the pieces that you must take care of and leaves a lot of open space for the rest of it. So the proposed solution is just simply make the packet fatter. And in this case, I'm suggesting zero pad the rest. This is where we get into discussion. Next slide. So the draft is in its initial state of just saying, this is a problem. Here's one thing we can do about it. And it has some interesting questions embedded in that space as well. One of the things that was, why would you want to zero pad it? Why not actually stick a bit test pattern in there? We've actually had other people respond as part of that mail chain that got kicked off that they actually have strong interest in this being done to actually do bit pattern tests. My response back to them is, do you really want your line card doing jumbo frame pattern test at BFD line rates? The usual thing that as chair I ask everybody, do you want your implementation doing something every 3 milliseconds? Answer, probably not, but in the case of the application question, something that does this type of probing slower might be perfectly fine. So there's at least interest in that. Other reason of do some level of zero padding. Again, this is a bit of hackery that we've been holding our back pocket for. How do we extend BFD if we need to at some future point in time? One of the options is just drop something at the end of the BFD packet outside of authentication. This is partially what was done with OSPF, but leaves open the obvious question of what to do about securing that or not. And of course, the question becomes, do we need to actually negotiate this? Literally, you could today just do this type of fat packet, send it across the other side, and if the packet doesn't get through, you've partially proven your point. Greg.
Yes, Greg Mirsky, ZTE. I do think that it needs to be negotiated, because if expected behavior for asynchronous mode that the same size packet should traverse back, then we need to know that the far end thinks that they can send it.
So it is my impression from customer discussions, at least, that the paths may be asymmetric, in terms of MTU, and that's okay.
Again, right. So we already have possible asymmetry in timers intervals. So if we allow, and extending this, if we allow packet size to be asymmetric, that needs to be negotiated.
Or at the very least, it's declared by configuration.
Or to be by configuration.
Right. So there's certainly room in here. We have two things that are, what to do and in various levels of options. These things become very difficult to wedge into BFD v1, and leads to other possibilities. George?
So there are various platforms that have baked pieces of BFD implementation in silicon, and it would be good to do a poll to see if those boxes would be expected to use in this environment, and if they are, that they can handle the packet size.
Yeah, minimally the behavior I'd expect if something can't handle is, for example, we had our own implementation that Juniper looked at. Once upon a time, we actually were able to take, packets of arbitrary size of the line card. The group in our PFE land actually decreased the maximum packet that could get through to about 500 bytes, originally to deal with a specific DDoS bug that had come in from customers.
Yeah,
but your point being that, for example, Broadcom's implementation expects this to be minimally encapsulated.
right.
That's okay. The session would fail. We just should not use it in that circumstance. The question being, should this be negotiated?
Yeah.
Yeah.
Actually, I think that the point that George makes is, I will interpret it as an argument for negotiation, because that makes figuring out whether you use it or not much more clear.
Right. Next slide, please. So this is meant to be a teaser. There's a use case here. I think that this may be an interesting thing to solve. And I think this is yet another case where we're starting to run into the wall of what clever things can we do with existing BFD v1 without sort of abusing the protocol. And perhaps this is yet another case that v2 is something we should look at. Tony.
Tony Lee. Like to suggest that you also mention setting the DF bit.
That is actually mentioned in the spec.
Okay, thank you.
So this is not yet the call for working group adoption. This is mostly to act as a teaser to start getting people thinking about, is this something we should work on? I'll continue to prod this on the mailing list. And as I mentioned, this is potentially another piece of support of, is it time to start talking about BFD v2? That said, this is the last presentation. We are miraculously on time with a full schedule. Go forth and have cookies. So we just to expand on what that directly proxy is about. We talked about this. When you look at 5880 demand mode procedure, nothing's really changing in terms of how demand mode actually gets used. What is, I think, a clarifying step is that in the 5884 style environment for OS's encapsulation, a tiny bit more guidance is given how it can be. So all the flexibility is already there in the base specs. This This is more a